everyone, Miss Meek here, and today we are going to talk about equivalent ratios. Equivalent ratios. Now, equivalent ratios are really important because we have to be able to determine if two ratios are actually the same. And so one way, we're going to talk about several different ways to do that. Some of the ways, or one way, is to reduce them down to the simplest form that ratio can take. Another way is going to be to multiply it up and see if we can get the two ratios to equal each other. We will also talk about a third way where we try to get just equivalent ratios one way or the other and see if they'll equal the same thing. So we're going to learn several strategies today on how to find equivalent ratios. The first way we're going to talk about is to reduce our ratios to simplest form. Okay, so if we reduce them to simplest form, we will be able to see if they are exactly the same or not. So we have two ratios here. So are these ratios equivalent? Here on number 1, it says 14 blue balls to 8 green balls. So this is my first ratio right here. So I have 14 to 8. And I want to write these as fractions because it's a little bit easier to simplify them when they're written as fractions. To simplify, I want to divide by a number that the top and bottom have in common. That number for this one is going to be 2. So I end up with 7 over 4. So my reduced fraction for this first ratio is 7 to 4. Now I have a second ratio right here, 28 blue balls to 16 green balls. Again, that's going to be blue over green. So my second ratio is going to be 28 over 16. I'm going to go to simplify this one. To simplify this one, I'm going to divide by 4. And when I do that, I get 7 over 4. So now I need to compare my simplest fractions. Simplest form fractions. Are they the same? Well, yes, they are. So because they are the same, yes, these two ratios are equivalent. So when it asks, are they, we can absolutely say yes with 100% certainty because our simplified fractions are the same. Let's take a look at number 2. Are these ratios equivalent? It says 10 red cars to 2 blue cars. So there is my first ratio right there. That's going to be 10 over 2. I'm going to simplify that by dividing by 2. And when I do that, I end up with 5 over 1. So my first ratio is 5 over 1. My second ratio is 4 red cars to 2 blue cars. That's going to be 4 over 2. And when I simplify that one, I am going to divide by 2 as well. And I end up with 2 over 1. So are these ratios equivalent? No, they're not. One of them equals 5 to 1. The other equals 2 to 1. So those are not equivalent. So when it says, hey, are they equivalent? I would say no, not equivalent. That would be my final answer here. Not equivalent. They are not the same. So that's one strategy that we can do. Another strategy is to prove that we have equivalent fractions. So I'm going to try to get one of my ratios to equal the other ratio using multiplication or division. So here in this problem, number 1, are these two ratios equivalent? I have 7 cats to 5 dogs. That is my first ratio. Again, I want to write these as fractions. A little bit easier to work with if they're written as fractions. And I'm going to set this ratio equal to my second ratio, which is 35 cats to 25 dogs. Now, my whole purpose is trying to see if I can use multiplication or division to get my first ratio to equal my second ratio. Well, I noticed that if I multiply 5 times 5, I get 25. So, yay for that. Okay. Now, whatever I do to the bottom of a fraction, I have to do to the top. That's what makes equivalent fractions. So if I can multiply 7 times 5 and get 35, then I do in fact have equivalent ratios. So is 7 times 5 35? Yes, it is. So I do have equivalent ratios because I could get one of my ratios to equal the other using multiplication or division. We do have one more strategy. We can compare unit rates. So I can divide my ratio down to the unit rate, meaning that I'm going to have a number over 1. Okay, a unit rate is a rate that has a denominator of 1. So let's investigate that. Just as a quick refresher, here's my first ratio. To find the unit rate, you divide by the denominator, okay? So make sure that you're dividing by the denominator. So I'm going to divide by 3. When I divide by 3 for this first ratio, I get 5 over 1. So that is the unit rate for that first ratio. My second ratio is 20 over 2. So again, I divide by the denominator. So I'm going to be dividing by that 2. So 20 divided by 2 and 2 divided by 2, there we go. I get 10 over 1. So the unit rate for my second ratio is 10 over 1. Are they the same? No, one of them is 5 to 1, the other is 10 to 1. So these ratios are not equivalent. So to answer the question they asked, are they equivalent? The answer is no, they are not equivalent. So that is 3 different strategies you can use to compare ratios with some examples there. Our whole goal is to determine, do I have equivalent ratios? Because if I do, I can use them to find other pieces of information. I can use them to find missing pieces of information, and I can use them to find other equivalent ratios. So they're really helpful. But if we don't have equivalent ratios, we can't do all of that. So step number 1 is to determine, do we? And you just learned 3 new strategies that can help you determine and answer that question. All right, I hope this helps. I will talk to you later. Bye.